if we take the rate laws, use calculus and integrate them, we can get the rates with respect to time. This is the first order, this is the second order, and this is zero order. And these are the same as the regular rate laws. Stuff like this, but all that's been done is just been integrated. So I have time to work with now, and I can solve a whole new set of equations using that. And one more thing that is useful experimentally is the plots to determine whether or not something is a first order, second order, or zero order. In order to determine what order it is, what I will be looking for is to plot the natural log of the concentration 1 over A of the concentration, or just the concentration versus time, and whichever one gives me a straight line, that is what it is. If the natural log of A versus time gives me a straight line, the plots, then that reaction is a first order. If it's this one, and it gives me a straight line, it can go up or down, it doesn't matter what the slope is, as long as it's a straight line, then it's a second order. And if this gives me a straight line, then it's a zero order. That's another useful thing to know. But one popular use of these integrated rate laws is to solve for half-life, and probably should have put those up there, but to solve for half-life, it's pretty easy. All I do is take the second concentration and substitute something like this in. So for a first order natural log, A0, I forgot to go over, A0 is the primary concentration, and then A is the second concentration. So I can find a particular concentration, I can be given two concentrations and solve for time, or I can have time and a primary concentration and find the second concentration, or I can have a second concentration, time, and then find the primary concentration. So there are a lot of things that can be done with it. And one of the things is the half-life. Something like this. And then the half-life, I'm just going to replace the second concentration with the first concentration divided by 2. So these would cancel out, the 2 would flip, so it would be natural log of 2 kT. It's all simple enough, and these ones are basically the same idea. I would replace this with, and then I would solve.